This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to section 5.6, day 2. This is graphs of exponential functions with base E and applications. So check this out. We want to graph y equals log base 5 of x. And the big strategy is going to be to convert it to exponential notation. So you get y is the exponent, 5 is the base, and x is the power. So you can switch these around and rewrite it as 5 to the y equals x. Looking at that kind of an equation, it's way easier, as you can see, to choose the y values and back calculate the x values. So you choose the y values, your standard -2 up to +2, and you can calculate x. So 5 to the 0 equals x. Well, that might be the easiest one, because anything to the 0 is going to be 1. 5 to the 1 is just 5, and 5 squared is 25. The negative ones are going to be 5 to the -1, and anytime you see an exponent of -1, you can take the reciprocal, because negative exponents indicate fractions. So this is 1 over 5, which is just a 0.2. Decimals are easier to graph than fractions, so we're just going to put 0.2 right here, and then 5 to the -2 is equal to x. That's 1/25. That's 0.04. When you graph these, it looks like this. It's a flipped exponential function. This log right here is the graph. And as you can see, we plotted the points. 1, 0, 1, 0 is right here. 5, 1 is right here. And 0.2, -1 is right here. This would be 0.04, -2. Instructions say graph each as a transformation of the parent function, and y equals natural log of x. Give the domain and vertical asymptote. Well, let's just make sure we've got our a handle on y equals natural log of x. So if you try and put 0 into the natural log of x, you get an undefined number, and as well as any negative numbers. The natural log has as its domain all positive numbers that are all the numbers greater than 0. If you input 1, you get an output of 0. Input 2, you get an output of 0.69. And if you input e, or something close to e, you get 1. And that's a rounded number. So we've got the f of x is equal to the natural log of x plus 3. I'm going to say that's the same thing as x minus -3, because here, when you answer the question, it's x minus what? That's how much horizontal shifting you'll do. It's x minus -3. It's a horizontal shift of -3. And so we can see that the asymptote used to be at x equals 0, now it's at x equals -3. It becomes -3 undefined, -2, 0, -1, 0.69, and -0.18, 1. It's basically these same y values, except they've been shifted over 3 units. The domain is not 0, infinity, but -3, infinity. The vertical asymptote appears at -3. That's where that is. Here, it might be just easier to plug in the values 0, 1, 2, and 3 into the function and just see what you get. And there they are. They're plotted 3.7, 3, and 2.6. But how do they get that way? Well, it's because you've got a vertical shift on the parent function, natural log of x, of +3. And you've got a vertical dilation of -1/2. That's because you can rewrite this as 3 plus -1/2 times natural log of x. So those things are not going to affect the domain, which is 0 to infinity, not inclusive. And you've got a vertical asymptote of x equals 0 right here. Lastly, we're going to get the absolute value of x minus 1. Now, yes, you can see it's a horizontal shift of +1 because there's an x minus 1 on the inside of the function. But on the outside of the function, we've got a absolute value reflection. That means vertically, anything that goes below the axis is going to get reflected up above the x-axis. This used to be a nice exponential or logarithmic curve right here. it's very flat, and then all of a sudden it drops down and it gets very steep here. Well, that steep part is going to be reflected up, because any negative values you get out of the function, they're going to become positive values, because the very last thing you do is take an absolute value. Anyway, the domain is going to be 1, infinity, because we have horizontally shifted the whole graph over 1. It used to be a 0, infinity, now it's a 1, infinity, because there's an x equals 1 asymptote right here at x equals 1. Anyway, I'd like you to start assignment 5F2, copy the problem list, do the first problem, and I'll see you in class.